of the process we discussed in class of subtracting fractions. This is the problem I am presented with. I'm going to box it at the top so we'll see that it's separated. This is what I'm presented with. And when I take a look at these fractions, I notice that they do not have the same denominator. So this cues me that what I need to do is stack those fractions and create my equivalent fractions so that I can carry out my subtraction. The way that we practice doing that is zeroing in on 7 and 4. 7 and 4 are our denominators, and I'm going to need to find the LCM of 7 and 4. The way that we've practiced doing that in class is either listing multiples and finding the first multiple that you have in common, or we have practiced that more efficient strategy, which is zeroing in on the larger number, which in this case is 7, and listing multiples of 7 until you meet a number that is also a multiple of 4. Once I get to 28, I see that that is the least or the lowest of the multiples that they have in common. That's the first multiple that they share, therefore it's the least. Since they share the LCM of 28, that's a shared multiple, that becomes my denominator. I'm going to plug 28 into the denominator position in both of my fractions. That'll work. And I can also go ahead and plug 28 into my answer's denominator. Now I'm going to work one fraction at a time to create equivalent fractions. I know that 4/7 can be turned into an equivalent fraction with a denominator of 28. So I'm going to ask myself what that missing factor is. 7 times what gives me 28? Well, I know that 7 times 4 gives me 28. Whatever I do to the bottom, I'm also going to do to the top. 4 times 4 gives me 16. I'm going to do the same thing with this fraction to create its equivalent. 4 times what gave me 28? Well, I can plug 7 in there. Whatever I do to the bottom, I'll also do to the top. I'm going to plug 14 into the top. Now, it's important to note that I've just created an equivalent fraction. 4/7 equals 16/28. They have the same value. I multiplied them by a value that equaled 1. I just did this in order to create those equivalent fractions so that I can carry out the computation. Now that I have 28 and 28 as my denominator, I can clearly see why I already have 28 in my answer's denominator, because I'm comparing wholes that are broken into equal parts. Now I just take 16 and I subtract 14 from it. When I do that, I get an answer of 2/28. Now that answer is correct, but it can be simplified. 2 and 28 have shared factors. If I come to the side and I list those factors, I'll find that the greatest factor that they share is 2. Therefore, I divide out the GCF of 2. What I'm going to do in this step, in order to get 2 divided by 2 is 1, and 28 divided by 2 is 14. This is the correct answer in simplified form. So 4/7 take away 2/4 equals 1/14. Now, this is a subtraction problem where I simply had 2 fractions that I was subtracting. I want to do an example where we take a look at borrowing and regrouping, because just like we can borrow and regroup in whole numbers, we can also borrow and regroup with fractions. And this is an important 5th grade skill. So I want to do a video where we talk through this process. This sometimes can be a stumbling block until we really practice and make sense of what we're doing. Now, I see 4 and 3/5. I'm going to lose or take away 1 and 3/4. I know this is possible because this value is larger than this value. Let me box this, because this is our starting point. Underneath it is just the way that we're going to compute, the way that we're going to figure this out. Well, I have 2 fractions here, and when I zero in on the fractions, I notice that their denominators are not the same. I have 5 and I have 4. My first step is to create equivalent fractions. so I can compare like values. Going to use the same process we just talked through. I'm going to find the LCM of 5 and 3. Well, the LCM of 5 and 3, I can skip count by 5 until I meet something that is also a multiple of 3. And sure enough, here we are. 15 is that LCM. Oh, you know what? I should be doing the LCM of 4. Let me adjust this. And guys, as mathematicians, this is what we do. Sometimes we make an error. Hopefully, as we make sense of it and go back to check ourselves, we find that error and can fix it. But that's okay. That's part of being a student, being a mathematician. So let's take a look and let's find our new shared factor now that I'm considering the right numbers. I have 4 and 5 because those are my denominators. 5, 10, 15, and I'll continue it to 20. Now 20 is the first shared factor with 4. So 20 will be what I'll plug in to my denominator position. 20, 20, and 20. Now I'm going to create those equivalent fractions. 3/5 equals what over 20? Well, I know that my missing factor is 4, as 5 times 4 equals 20. Whatever I do to the bottom, I'll also do to the top. 3 times 4 is 12. Come down here, I notice 4 times what equals 20? Well, that's going to be 5. Therefore, I'll multiply my numerator times 5. 3 times 5 equals 15. Now, what I like to do is I like to go ahead and at this point rewrite my whole numbers so that I don't forget about that whole number value. That's a common error that we make. We do all that work with the fraction and forget about that whole number. So when I take a look, I see that 4 and 3/5 equals 4 and 12/20. Just like 1 and 3/4 equals 1 and 15/20. I've just created equivalent values but have a like denominator. So at this point, I'll carry out my subtraction. 12 take away 15 won't give me anything positive. So just like in whole numbers, I'm going to borrow from my neighbor value. My neighbor value here is the 4. So I'm going to cross off the 4 and I'm going to take 1 away from it. 4 becomes a 3. Now I have a whole floating around and I want to give that whole to this numerator. But I have to decide what the whole is that I'll give it. Whatever's in the denominator position, I'm going to give to the numerator because look, it's like adding 20/20. 20/20 equals a whole. I would simply add 20 to 12. So my numerator is going to be 32. This is what I did. I just gave it a whole. So now what I'm going to do is I'm going to carry out the actual subtraction. Now that I have a value up here that I can lose 15 from. So if I have 32 and I lose 15, the difference is 17. Now I'm going to take 3 minus 1, and those whole numbers, once subtracted, give me 2. I can clearly see my answer is 2 and 17/20. This is already reduced. These two numbers share no GCF other than 1. That's the greatest common factor that they have. So the answer is already simplified. And my answer is 2 and 17/20.